Okay, greetings. Today Dwight, along with Jose and Jovan from Group 6, we will present the results of our research entitled Predicting Students' Timely Graduation Using CART. As the title suggests, our goal is to create a model to predict the likelihood of students' timely graduation, and then see how accurate the model based on our dataset, which we obtain through Kaggle. In this study, we will use the decision tree algorithm to model the prediction of students' on-time graduation. Our dataset has a total of 23 attributes, including students' academic results, personal attributes, and economic circumstances. In addition, through this research, we would like to see which attribute from our dataset play the biggest role in determining the success of a person graduating on time. In addition, we will also assess the effectiveness of decision tree algorithm in using it to create a prediction model like the one we designed. The three main targets that we want to achieve through this research includes the first one, designing a prediction model for students on-time graduation. Second one, identifying what attributes have the most significant role in determining the timeliness of graduation. The third one is assessing the performance of the model we designed with the decision tree algorithm. Okay, as I said before, this research aims to design a decision tree model using the CART algorithm based on a dataset containing student academic grade attributes, personal attributes, and student economic circumstances. The accuracy of the model will be considered with several assessments such as uh, precision, recall, and F1 score. Hopefully, the results of this research can help students or universities to provide an overview of graduation time and improve student academic performance.
Okay, so on the second chapter, we discuss about some previous work that have been done similarly to our topic. These researchers seem to be producing high accuracy rates in predicting F1 score in comparison to other machine learned algorithm. Most of them resulted higher than 60%, which is good number for a decision tree algorithm. However, there are some limitation in these researches, such as most studies only predict F1 scores in specific subject, or have a limited set of variables which could have an effect on the overall score outcome. On the bright side, these limitations could be the next topic of future researchers to dive down into and present their new ways of predicting F1 scores. The next topic will be brought on by Jose.
And this is the explanation of our work plan that has been broken down into different sections. The first one being data collection. In this phase, our primary objective is to gather appropriate data for our research. We have sourced the data set from Kaggle, which consists of 34 attributes such as marital status, parents' occupation, and curricular units in the first and second semesters. The dataset contains a total of 4,424 entries. Most of the attributes in the dataset are numerical, except for the target attribute, which can have the values of either graduate or dropout. In the second phase, feature selection, our analysis, we utilized a CART, which stands for Classification and Regression Tree, Decision Tree Model. Typically, this model is best suited for handling features with numerical values, as it makes splits based on numerical thresholds at each node. However, since our dataset only contains numerical values, we have decided to include all available features for testing purposes. Next, model selection. In order to achieve the desired outcome, we need to create the best possible model. This involves exploring different combinations of variables and relationships to find the optimal solution. In the results section, we will extend further on what attributes scored the highest importance score. In model training, once the model is designed, we will commence training process by processing the data. The model will undergo multiple training sessions, repeatedly processing the same dataset to observe if it will produce consistent results. Only when the results are consistent Only when the results consistently converge with the training process, it will be considered complete. Next, once we have trained the model and its results, our priority is to analyze and evaluate them. One method of evaluation involves comparing our findings to previous research in the field. We will assess whether our model can make more accurate and useful predictions compared to the existing approaches. In the results and discussion section in our study, we focus on evaluating the effectiveness of our decision tree model in predicting timely graduation. We utilize the skkit library in scikit library in Python for training and evaluating the model. The dataset we worked with consisted of three main categories of factors: personal attributes, academics, and economics. After splitting the dataset into training and testing sets, we proceeded to train the decision tree model using the training set and evaluate its performance on the testing set. During the evaluation, we calculated the accuracy of the model, which measured how well it correctly predicts its timely graduation. Our decision tree model achieved an accuracy score of 68.813%. This indicates that our model is relatively effective in predicting whether a student will graduate on time or not. Additionally, as part of our analysis, we examined the feature importance obtained from the trained decision tree model. This allowed us to identify the most significant attributes that contribute to predicting timely graduation. The top attributes ranked by importance included curricular units, age, enrollment, tuition fees, and course. These attributes had a substantial influence on the model's classification rules and attribute splits. We also calculated the F1 score to evaluate the performance of our decision tree model in predicting timely graduation. The F1 score is a metric that considers both precision and recall, providing a more comprehensive assessment of the model's effectiveness. In our study, the F1 score obtained for the decision tree was a score of 0.69, which indicates a reasonably good balance between precision and recall for predicting timely graduation. Furthermore, the accuracy of the model was calculated to be 0.68, which aligns with the accuracy score mentioned earlier. The accuracy represents the percentage of correctly predicted instances out of the total instances evaluated. These scores further reinforce the effectiveness of our decision tree model in predicting timely graduation. The F1 score takes into both account precision and recall, while accuracy score provides a straightforward measure of overall correctness. Next, we identified the most significant attributes for predicting timely graduation, and these are the attributes ranked by importance were as follows. The first one being curricular unit second semester with an importance score of 0.35, following with a curricular unit second semester score enrolled with a score of 0.45. We can see the disparity between these two scores by a score of 0.29. And we also have attributes such as age of enrollment, tuition fees up to date, curricular units second semester, and also curricular units first semester.
So this is the result of our decision tree model. The tree itself is made based on entropy scores of students from various subjects, and the branches of the decision tree, on the other hand, are made from the standards and requirements that we have set on the model. As we discussed earlier, our model reaches a staggering number of about 0.7%, which is very good for its kind, but lower than previous researches. The limitations that keep us from reaching a better score is the lack of good data that we could collect. Many attributes in our dataset did not meet the required criteria, and the provided variables were insufficient to develop the internet model, but we are happy with the result of our research. Next, we will show you our references. Okay, so the first one is from V. Tinto with the title Leaving College, Rethinking the Causes and Curses of Cures of Student Attrition. And the second one is L. Brayman with the title Classification and Regression Trees. The third one is Keeley with the title Prediction of Student Graduation and Dropout Using Decision Tree, a case study of a Korean university, International Journal of Engineering Education. And the fourth one is Tirunarayan with the title Predicting Student Performances in an Online Course Using Decision Tree in Proceedings of the 2013 AESM. The fifth one is a written with the title Data Mining, Practical Machine Learning Tools and Techniques, and the last one is J.S. Friedman with the title Classification and Regression Tree. Okay, that is all for our presentation. We hope that you find this useful, and we from the group 6 say thank you for listening.